1 is asking to integrate terms as they occur after a partial fraction decomposition. Our first term is the integral over 1 over x minus 1, as 1 is almost the same as 1 over x. 1 over x we could integrate, so 1 over x minus 1 is simply as antiderivative the logarithm of x minus 1 plus c, and that's where we are. Right, the next integral in part b is very similar, just we don't have x minus 1 in the denominator, but we have x minus 1 squared. Well, to make it easier, we could say this is the integral over x minus 1 to the minus 2 dx. Now, how do we integrate this? Again, if it wasn't x minus 1, we would know how to do it. It's just a linear substitution. So what we get as antiderivative is x minus 1 to the minus 1. Now to make up for the outer derivative, this will give us a minus 1 when taking the derivative, so we need to take minus plus c, or if we like to write it out in more detail, this would be 1 over x minus 1 plus c. And that's it. Part C, now we have something slightly more complicated. We have x plus 1 divided by x squared plus 1. This is already the result of a partial fraction decomposition, so we don't know how to deal further with it by partial fractions. So if we have something like this and we don't know how to do it further, we can always split up the fraction according to the terms of the numerator. So this is the same as x over x squared plus 1 plus 1 over x squared plus 1. Okay. Well, this looks already much better because now we have two summands where we basically have an idea how to do. Here we do a substitution, and the other one will give us an inverse tangent. Okay, so let's do this. Let's do our substitution in the first term. What do we do there? We could substitute x squared. In fact, it turns out to be even easier to substitute x squared plus 1. If we do this, what is our derivative? What is du? Well, du is equal to 2x dx. That's our substitution. Doing the substitution, what do we get? We get the integral over our denominator x squared plus 1 now just becomes u. What happens with the numerator? We have x dx, which almost is what we need to do to substitute the u, but we need a factor 2 there, so we get 1/2 1 over u du plus, as mentioned, the second summand we can integrate directly. This is an inverse tangent, so we get the inverse tangent of x plus integration variable c. Finally, integrating 1 over u is easy. This gives us a logarithm, so we get 1/2 times the natural logarithm of u. Well, u was x squared plus 1, so this is the natural logarithm of x squared plus 1, plus the inverse tangent of x plus the integrating variable c. Okay. Finally, part D. Again, we have a more complicated fraction. We have x plus 1 over x squared plus 2x plus 2. We could try to split up the numerator, but that doesn't resolve the issue of the denominator being more complicated. So let's first, in the auxiliary calculation, complete the square. Okay. We want x squared plus 2x plus 2. And we want to write this as something squared plus something. We do this by basically looking at the binomial formula. So we have a term of 2x in here. So if we want to write this as x plus something squared, we need to pick x plus the half of 2, which is 1, so we get x plus 1 squared. X plus 1 squared by the binomial formula would be x squared plus 2x plus 1, but we want 2x plus 2. To get this right, we need to add 1 more. Okay, so doing this so, our integral now becomes the integral over x plus 1 divided by x plus 1 squared plus 1. Integrating this again is rather easy. We do a substitution either of x plus 1 or x plus 1 squared, or we even could substitute x plus 1 squared plus 1. So let's say u is equal to x plus 1 squared plus 1. Then we know that du is equal to 2 times x plus 1 dx. This makes the substitution rather easy. Our denominator just becomes 1 over u. We need to make up the numerator 2x plus 1 x plus 1 dx we have already in the substitution, but there we have an extra factor 2. To make up for this extra factor 2, we need to add 1/2 at the front of the integral as a factor. So we have 1/2 integral 1 over u du. We know what an antiderivative of 1 over u is. This is a logarithm. So we get 1/2 the natural logarithm of u. What was u? U was x plus 1 squared plus 1. So we get x plus 1 squared plus 1 plus c, and that is our integration.